I think display also is quite good. I think I cleaned the camera. I think display also is quite okay. Display and voice both are okay. If display and voice both are okay, I will start. Both are okay? Okay. Now, start now. I told yesterday only, second question, already first question completely over SFD BMD. At the end of yesterday's class, I told second question, these 2 points are hinged. These 2 supports are hinged. So, solve by SD method or MD method or Conics method, final moments are here. I have not entered because yesterday class, at the end of the class, I entered. Yes or no? Yesterday, at the end of the class, I entered it. So you should refer yesterday's class. That is class number 23. Tell me yes or no. I entered the answer. Yesterday, at the end of the class, I entered the moments. Okay, then, yesterday's class, I told you how to find all the reactions. All the reactions. Then, I told using the same principle for this question also, find all the reactions. See, I calculated and entered everything. One answer was not coming. Nandakumar sent 26.37 I wrote here. He told 26.37 and 73.63. He told different answer. Then I calculated. I got 71.63, 28.37. But today, he sent me a correction. He told this moment he took, instead of 58, he told he took it as 68. Okay. 68 by 5 is 10 difference. Correct now. See, 10 difference. 10 divided by 5 is 2. That's why he got what? Here 2 kilonewton lesser, there 2 kilonewton more. Because this couple will increase the reaction there, decrease the reaction. Anyway, now okay. He already sent a correction to me. I saw it now. He told I took wrong moment. Okay, now these are the free body diagrams for all the members. Correct? Remember now? See, this moment is not there. 0. That moment is 0. I told you yesterday only. Because anyway you see solution. Even this moment also 0. Remaining all same as last time. Only change is numerical difference. Okay. Then I got another 3-4 people sent me reactions. I checked it. Correct. So reactions are correct. Tell me. Reactions are correct. If reaction correct, we will go for SFD and BMD now. See, I will start. First I will draw SFD. Where is that colored pen? One nimisha. Where I here. First I will draw SFD here. See, here I will draw SFD. BMD I will draw here. First I will draw shearing force diagram. Okay, see. How much it is? Okay, around 6 meter. I do not want to go beyond this point. 6 meter, 4 meter and 5 meter. This is 4 meter. This is 5 meter. Okay. A, B, C, D. See, A. This is B. I will write B somewhere here. Okay. A, B. Here I will go right side. Okay. A, B, C. C, D, E, F. All values are in kilonewton. Okay. First, draw happily shearing force diagram for the beam portion. Beam portion I need not explain. Why? You already solved plenty of questions. So start. SFD for the beams. When you want SFD for the beams, start from here. See, start. Go up by 100.51. 100.51. From here to here, come down by 30 into 6. So when you reach here, it will be 79.49. See, it will come 79.49. Nisha. Okay, right here. 71.49. This is the SFD for the beam. Okay. Plus minus sign. If you want left up positive, right down positive, you can write plus minus, that actually not required. Okay, start. Then draw SFD for BC portion. See, over. Go up by 79.49. Then at B, go up by 92 kilonewton. 100 point there, little lesser. 92. No load up to here. Then come down by 200. Exact center, come down by 200. So this ordinate will be 108. Correct? Yes, 108. 108. No load, go back and close. Over. Go up by 108. SFD for the beam. Lastly, SFD for CD. Go up by 108.5. Little more. 108.5. Go no load for 2 meter. Come down by 150 kilonewton. That will be only 41.5. No load, close. Okay. SFD for the beam. Now, if you observe SFD, there is a new point here where shearing force diagram crosses baseline. Already A, B, C, D, E, F over. I will take the point as G. I want this distance X. Calculate X. If you cannot calculate X, you are wasting time attending my class. 100.51 divided by 30. It will come 3.350 meter. Calculated. 3.350 meter. Enter the value. See, one more point is there. That is exactly the load point. E, F, G, I to H I will call. One more point is there. I will call I. That is, this point is H. This point is I. Then draw shearing force diagram for the column. It is your choice. See, for a column, shear force is what? This way. You can take either this positive or this positive. Your choice. No point in wasting time. You start from here, go with the load. Start from here, go with the load. That will take care. Start from here, go with the load. Start from here, go with the load. Start from here. Go left side by 28.37. Very small. 28.37. No load for 3 meter. Up to 3 meter. See 71.49. I write here. Up to 3 meter, there is no load. Then, actually 28 should be little lesser, because why? This is 41. So it will be lesser. Okay. How much it is? 28.37. No load up to somewhere here. Okay. Then go right by 100. When you go right by 100, this ordinate will be how much? 71.63. No load up to here. Once again, go back by 71.63. See, this is the shear force diagram for the BE member. For this member, you start anywhere you want. There is no rule. Start from bottom. Go right side by 132.88. 132.88. From here to here, come left by 60 into 4, 240. So when you reach here, it will be around it is 107.12. No place right here. 107.12 joined by a straight line. Okay. This is the shearing force diagram for the other column. It will cross the baseline here. That distance required. See now. One point comes here. That is A, E, G, H, I. I will call this point as J, and this point where SFD crosses baseline, I will call K. That X you require from here. That X will be, someone will tell, he is not explaining. I will not explain those things. Why? This is advanced part. Divided by 60. 2.215 meter. 2.215 meter. Okay, calculate. Okay, now do one thing. To understand correctly, I will mark all those extra points here in a red color now. See, there is a point here G, somewhere here, a point G. Distance from here is how much? 3.350 meter. It is little further that side, not there. It is somewhere here. See, there is a point called G here. The distance from here is 3.350 meter we got by SFD. There is a point here, already standard point H. One more standard point I. There is again one more standard point here J. Here SFD crosses baseline at 2.215 meter. Somewhere here. Okay. That point I will call K. That K point from here is 2.215 meter. Calculated value, I will round off. This is the shearing post diagram. Last time fully explained. I told more important is bending moment diagram. Clear fully? Shear post diagram, fully clear? 3.35. 3.35. Yes, correct. I wrote correct. 3.35. Correct. What is wrong? 3.35. Correct. Fully clear. Okay. Now, the most important is bending moment diagram. I will do one thing. For space, I will remove this left side. I want more space and I want to explain something. So, shearing post diagram, I will remove, and what are the extra points I located there. Okay, start. We want to have the shear post diagram now. Now, important is bending moment diagram. Remember, I will explain once again today. See, start. First, I will draw bending moment diagram. That is the actual technical bending moment diagram, not crude method or superimposing method which people use in examination. That superimposing principle will not give correct BMD. It will give only shape of the BMD. It won't give you maximum value solve. So that is only for examination. But correct concept is correctly find bending moment. Anyway, once I finish the correct concept, I will tell you superimposing principle for those who never know these things. BMD we will draw on tension side. Tension side. See, now, first consider horizontal members. Horizontal members. That is AB, BC and CD. I will do one thing now. See, here some gaps are there. Actually, there is no gap. So what you do? You draw the member once again. There is no gap there. That gap is pure imagination. Okay. See, I will draw here. Neatly, not project it here. See. A, B, little bigger. Okay. B, C, D. Then BE 5 meter, CF 4 meter, sufficient. A, this is B, where tension comes. B here, then here tension comes that side. C, D, E and F. I am drawing what? I am drawing BMD on tension side. This is the correct concept. Then all values are in kilonewton meter. Remember, when you draw BMD on tension side, you make a note. To draw BMD on tension side, you should make a note. For calculation, use sign. Use sign. But while drawing BMD or while plotting, sign is nonsense. Sign is nonsense. Clear? When you calculate, use sign. But when you plot it, sign is nonsense. Some people have seen, they draw BMD on tension side, use minus plus sign. Utter nonsense. They should know at least that much basic concept. If that much is not known, they should silently go for superimposing principle and wash their hands off. Okay. Now, what you do for beam is, see, what you will do? When we calculate, we will use sagging positive. Then, sagging positive. Then, see, I write here now, sagging positive. Then, get the answer. get answer, that is bending moment anywhere with sign. With the sign get the answer. Then if the answer is positive, that means it is sagging. It is sagging only. Sagging, tension will come this side. Plot the value on which side tension is coming. So for beams, if it comes positive, tension is below, plot the value below baseline with no sign. And if we get negative sign, see, negative, that means the bending moment is hogging. Hogging means tension comes at the top. What do you have to? Plot the value without sign on upper side. That is for beam. This I told you earlier also, so many classes, but YouTube I not told much. Fully clear? This I told you earlier. YouTube class I have not told. I will tell later, not right now. Okay, start. Now, all this principle right here. Start now. For beams, first I will consider what? Horizontal member. AB, BC and CD. This. Start. To calculate bending moment, sign used is sagging positive. Okay, start. Bending, first AB member. I will do systematically. AB member. Bending moment at A. See here. When you find bending moment in the YouTube class, I uploaded 120 classes and more. I told each and every classes, people who tell clockwise, anti-clockwise, they are actually spoiling the subject. I have seen so many people come to left to right, clockwise positive, come to right to left, anti-clockwise positive. That is very, 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 very ugly way of explaining bending moment. When you can so clearly explain bending moment, even somebody on the road will understand. See, what they told is not wrong, but it is utter nonsense. Then I will ask the same person, compression tension, why you are not using? Coming from left to right, right side compression positive, left side negative, if compression positive, coming from left to right, right side negative, left side positive, if tension positive, coming from right side, left side positive, if compression is positive, right side negative, coming from right left side negative, right side positive, if tension positive. Oh, sir, that is problem, sir. Then, sir, you can easily understand. They will tell, sir, why, sir, that way? You can understand. See, compression, tension, oh, that you can understand. Then, why don't you tell the same correct concept here? So easy. Sagging, see, sagging, positive, hogging, negative. Do not use the word clockwise, anti-clockwise. Clockwise, anti-clockwise are direction based. I am shouting each and every class, whether it is offline class or online class, since past 40 years. Do not use direction for bending moment. I will tell nonsense. Somebody may tell, what nonsense? I will tell nonsense only. No, it is correct. I will tell it is correct, no doubt. Then let us have argument. I will start arguing with them. No, I don't want to tell what will happen to argument. Then, so correct concept. See, so crystal clear. Bending moment. See here. If you take a scale, sagging positive. See, hogging, scale is about to break. See, you cannot apply bending moment by one hand. See now, if you tell clockwise, anti-clockwise, tell me, is it bending moment? Is it bending moment? See, clockwise, anti-clockwise, is it bending moment? Is it bending moment? Clockwise, anti-clockwise, is it bending moment? You use the word clockwise, anti-clockwise. Tell me, is it bending moment? Yes, sir. See, clockwise, this is called bending. This is rotation, direction-based moment. Bending moment. Such a beautiful concept is there. Still people unnecessarily go for it. So I use a scale here. one big scale is here where I can very clearly show the bending moment, not required. Okay, something here, see, sagging, positive. One hand you cannot show bending moment. If you want to show bending moment or shear force or axial force or torsion, you require two hands. Sagging, positive. Hogging, negative. Therefore, when you calculate for beams, see, sagging, positive. Hogging, negative. Fully clear? First of all, I need not tell. Fully clear? Clear. Okay, now start. With that concept, start now. Bending moment at A, see, minus 111.01 kilonewton meter. I wrote already. No need of writing every time. All values are in kilonewton meter to save the time. That means the bending moment at A is no minus 111.01. Negative came, hogging. Tell me where tension will come. Tell me where tension will come. Top or bottom? Where tension will come? Top or bottom? I am asking for those who are newcomers. Those who are regular, they know it. No, where tension will come? Top. Therefore, tension at the top, simply plot the value here. Over, see, how much? 111.01. Some people, they will use minus sign here. Once again, height of foolishness. That minus sign is when you take bending moment diagram, if you write sagging positive, here nothing, over. Okay, start. Then bending moment at A over bending moment at G. See here, G. Look this side. Minus 111.01 plus 100.51 into 3.350 minus 30 into 3.350 is the total load. Minus 30 into 3.350 into 3.350 by 2. Tell me the answer. Tell me the answer with sign. I will take full class today so that any confusion yesterday, I will remove today. Any confusion yesterday, I will remove today. Answer with sign. Is it yellow? I wrote somewhere, then I rubbed it. I wrote it in the board somewhere, I rubbed it. Answer. What is the answer? Tell the answer. Is it plus 57.36? Is it plus 57.36? Tell fast answer. You should give the answer. You should participate in the class, not simply attend the class. Is it plus 57.33? Okay, it is plus 57.33. Now do one thing. That means the bending moment is what? 57.33. Positive came, sagging. If it is sagging, where tension will come? Tell me. Where tension will come? If sagging, where tension will come? If it is sagging, where tension? Tension comes where? If it is sagging. If it is sagging, tension comes where? You are taking lot of time. Next time I won't ask it. Bottom. So, bottom tension at that point where at 3.350 meter, that is the point G, you plot below by how much? 100 is there, 57.33. Okay, now lastly, bending moment at B. Look right side. Minus, no clockwise anti-clock, see, hogging, minus 47.97. That means it is 47.97 hogging. Tension will come at the top somewhere here. is 100.47.97 top. Now UDL joined by parabola, and this is the maximum sagging. Okay, now I will tell you one information. If you see the bending moment diagram, tell the bending nature from, see, there are 2 points here called points of counterflexure. If you want, you can locate. This I told in the class how to locate. Here not required. Now, from here to here, bend tension at the top. That means this way bending. So, this will hog, this portion will sag, this portion will hog. Or, if it is a RCC beam, see, you require top reinforcement here, you require top reinforcement here, you require bottom reinforcement here. Fully clear? These are all beyond our subject limit. Fully clear? If it is a RCC beam, full clear? This is the concept of BMD on tension side. Remember, and every software gives you BMD on which side? Whether you go for ETAP or SAFE or StatPro or any software, tell me, there, how you get BMD? Every software will not give sagging, hogging. It will always give BMD on which side? Every software will give BMD on which side? Any software, it will give on tension side. So, but one thing, StatPro people had made one mistake. They wrote BMD on tension side, then they wrote minus here. Actually, if I meet the StatPro people, I will tell them, a blunder you made. And one more thing they made. When the load is downwards, when you assign a load in StatPro, you have to assign minus sign. Okay, you had assigned minus 80. StatPro will show minus 80. This is the blunder StatPro has done. Because once you show, when you assign the load, it is upward positive. If you are downward 80 kN, assign minus 80. But display should come what? Display should come down 80. Down minus 80 should not come. It's a blunder committed by StatPro people. If I meet them, I will tell, at least rectify it. It looks so ugly to show downward load of minus 80 means it is upward 80. Anyway, but okay, people don't bother about it. Okay. This is a BMD for AB. If you want, lightly hatch it. Okay. BMD for AB member. Now, I will finish BMD for other 2 members now. Other 2 members. Easily I will solve. If time is not required. Now, consider BC. Little fast I will do. What all I should write? Bending moment at B minus bending moment at B minus 106.15. That is hogging. Tension at the top. Hogging of what? Hogging of not minus. See, not minus. That means it is 106.15 hogging. Tension top. Bending moment at H. Look this side. Minus 106.15. No into plus 92 into 2. Tell the answer. Here bending moment. Minus 106.15 plus 92 into 2. Tell the answer with sign. Fast. Don't waste time. Tell the answer with sign. Don't waste time. Plus 77.85. It is plus 77.85. That means what? That means 77.85 sagging BM, tension comes in the bottom. Then bending moment at C is, look this side, minus 138.14. That means what? 138.14 hogging tension top. So here tension top of 106.15. What is value? This value is 111.01. 106 is slightly more. Okay. 106.15 top at the point H center. At the H point it is sagging 77.85. Okay, sufficient. 77.85. Here it is hogging of, it is hogging, where I wrote, hogging of 138.14. 138.14, little bigger. 138.14. So join by a straight line, join by a straight line. Because point, no loading. BMD on, that means hog, sag, hog, top steel, bottom steel, top steel. Okay. No plus minus. Okay, next. Next member. Next member is which one? CD member. Okay, CD. CD member. Bending moment at C. Someone asked me, sir, if you look right side, you got minus 138.14. If you look left side, look left side. If it is not coming same, I will stop my teaching. Nodi, calculate money. Minus 106.15 plus 92 into 4 minus 200 into 2. Tell me, same value will come or not? Don't calculate. If you got confidence in me, tell me, same value will come or not? Don't calculate. Same value will come or not? Don't calculate. If you calculate, you don't believe me. Same value will come or not? Don't calculate it. It should be same, Allah. Compulsorily same. I told you, if it comes different value, that is the day when I stop my classes. No more classes. It has never happened so far. It will not happen now. It will not happen in future. As long as my memory or brain capacity is okay, that mistake will not happen. Okay. Now, come to CD member. BM at C here. Minus 92.48. 92.48. That is what? 92.48 hogging. Tension top. Then BM at I. Okay, here. I think better look right side. See, if you look left side, you have to consider couple and reaction. If you look right side, you have to consider only reaction. Plus 41.5 into 3. It is plus 41.5 into 3. Answer. Answer is plus how much? 3 5 15 1 3 1 3 4 4 12. Is it 124.5 positive? Is it 124.5 positive? Okay. That is what? It means, that means 124.5 sagging. Or if you want, do from left side. Minus 92.48 plus 108.5 into 2. It will come same answer. I will tell a joke for you after completing. Small joke. Okay. Bending moment at D. Last question, there was a couple here, therefore there was bending moment there. This time, tell the answer. BM at D, tell the answer this time. Last time there was a couple, fixing moment was there was bending moment. This time, BM, how much? This question, BM there, 0. That's all, 0. Therefore, here, how much? Left side, tension upper side of 92.48. This is rubbed out, 47.97. It is 92.48 here. 92.48, and at the point I, it is 124.5. 92, 124, little bigger. 124.5, 0 here. Join this way. Bending moment diagram means hog, only sag. Again, hogging is not there. Over. It will behave like a proper cantilever. Okay, now, beam, for the beam, BMD, completely clear. For the beam, BMD, completely clear. Okay, now, I will tell the joke for you. First of all, I am not interested in commenting. And I will not tell you where you have to see that video, where you have to go. I am not that type to insult someone. But there is a class in YouTube you do not know, views. It has got millions of views. 1.2 million or etc. I saw 11.2 lakhs etc. The person, he told so confidently, I will tell what he told. This is not to insult him. If he will go through this my class, he should rectify himself. He told, if you look this way, if bending moment comes plus, if you look this way, BM will come minus. So either side BM, if you add, you get 0. Ah, what a beautiful answer. He told, look left side. If BM comes plus, look right side. He told BM will come minus. Or sum of the bending moment on either side if you look. He told, answer is 0. Is it correct? Is it correct? Is it correct? BM, if you go from left side, whatever BM you get, if you look right side, you get opposite BM. Therefore, sum of the BM at any point looking either side is 0. Or he told what? He told that way. Whatever BM comes from left side and whatever comes from right side, they are equal in magnitude but opposite in direction. Therefore, sum of the BM is 0. Simple question for him. A simple question for him. A point load of 100. Reaction is 50-50. Distance is 3 meter. Tell the answer. Bending moment here. Look this side. Answer. Plus 50 into 3 plus 150. Tell the bending moment here. Look that side. Once again 50 into 3. Plus or minus. See. Look left side. Plus 50 into 3. Look right side. Tell me. Plus or minus. Plus or minus. Plus or minus. Look right side. Sign. Bending moment. Plus or minus. No moment. Look left side. Plus 50 into 3. Look right side. Plus or minus. Tell me answer. 50 into 3. Right side. Plus or minus. You, those who are my usual people should tell. Look right side. Plus or minus. Negative. Ayo, what is this? You are attending my class. Bending moment. Here. Plus 50 into 3. Look that side. 50 into 3. Plus or minus. You told negative. What is this? Bending moment. Sagging positive. If it is minus, he is correct. I am wrong then. Not direction. I told bending moment here. Here, 50 into 3. There also 50 into 3. Here positive. There also positive. You told negative. Why nobody is answering? Those who are present, at least somebody can answer. Whichever side you see, answer is positive only. Therefore, if you add the two bending, first of all, it is not two bending moment. The basic definition of bending moment. Consider only one side. Whichever side you consider has no effect on the answer. Actually, what he want to tell is, if you calculate algebraic sum of moment, then correct. If you take moment calculation, this is clockwise 50, that is anti-clockwise 50. So, if you calculate moments on direction based, then what he told is correct. Algebraic sum is 0, correct. But he is telling, the title is The Beautiful Trick of SF and BM. Don't search now. He told beautiful tricks of SFBM. Very popular. Then I got almost frustrated. This much mistake by a knowledgeable person. Okay, leave it. Why should you comment others? Why I am telling, let him at least correct now. Let him at least correct now. Okay, now, beam over. Now, the most important, that is what confusion you got last time. If at all you got confusion, That is for the column. 1 minute. Where I kept my... So here. I will tell you for the column. Okay, now. See, this I will remove now. Nothing required. Come to column. I will explain for the column thoroughly now. Come or consider vertical member. Now see, first make a note. The term sagging or hogging is crystal clear for which member? I will explain. I told yesterday, tomorrow's class I will thoroughly explain for you once again, because today time is there. Today there is no time problem. Yesterday time trouble was there. What I told, the term sagging, hogging. See here, the term sagging or hogging is crystal clear for which one? For which member? The term sagging, hogging is crystal clear for which member? For horizontal member. For horizontal member, that is horizontal beams. See, a beam, sag or hog, crystal clear. Now, when you consider a vertical member, see problem. A vertical member can bend like this, or a vertical member can bend like this. Tell me, can you tell this hogging, sagging? Can you tell it hogging, sagging? Possible? Tell me, will it be clear? Somebody to tell hogging, sagging, will it be clear? Vertical member, will the hogging, sagging will be clear? Hogging, sagging will be clear? No. But BMD on tension side will be clear? BMD on tension side clear? Yes or no? If you tell BMD on tension side, then it will be clear. If you tell BMD on tension side, yes, see, now, suppose for a vertical member, you tell hogging, sagging, it will not be clear. But if you draw BMD on tension side, something like this, oh, then clear. Why? Because from here to here, tension left side, it will bend like this. From here to here, tension this side, oh, it will bend like this. From here to here, tension this side, it will bend like this. Or, if you take one more member here, suppose the BMD is what? On tension side, like this. Then, again clear, see here. From here to here, tension this side, oh, clear. It will bend like this. From here to here, tension this side, oh, yes, bending this way. Here to here, tension right side, like this. So, for vertical member, full clarity will come if you plot BMD on sagging, hogging basis or tension side. Tell me. For vertical member, there will be full clarity if you draw BMD on sagging, hogging basis or tension side. Tell the answer. For vertical member, there will be full clarity if you draw BMD on which side? What? Sagging, hogging basis or tension side. Tension side is most powerful. But to draw BMD on tension side, you have to do calculation. So what you do is, during calculation, you assume sagging. Clear? You assume sagging. Clear or not? During calculation, you assume sagging. Clear? I will tell you now. During calculation, you decide randomly sagging. Clear or not? Depending on the load. Clear or not? Okay, now what you do is, see now, you consider member BE. Member BE. Member BE is here. See, this is member BE. B is here and E is here. There is a clockwise moment of how much here? 58.17. I will fully explain. Kn meter. No moment here. A load of 100 kilonewton here at 3 meter here. I am explaining once again. And there is a reaction here of 71.63 kilonewton here and a reaction here of 28.37 kilonewton here. Now, this is E, this is J. Now do one thing. Tell me, if you imagine the column to be like a beam, tell me, if it is simply supported beam, will it bend inwards or outwards? Will it bend inside or outside? You don't see fixed beam, simply supported beam. You imagine a simply supported beam. Apply load here. Tell me, will it bend inwards or outwards? Past. Will it bend inwards or outwards? After the class, write everything. Will it bend inwards or outwards? Inward, like horizontal beam. If you apply load for simply support beam, it will bend like this, inwards. Same way, I will do one thing. For bending moment calculation, I will take what? See, I will take bending in. See, this is the member here. This is the member here. I will take bending inwards. This is positive. Clear? Or I will call this as sagging because load is from this side. Tell me, fully clear? I will go inside the beam. See here, you come below the beam. Here load is that side, go to other side. Then bending this way, I will take sagging. Your choice. Clear? Clear or not? Bending inside. In the direction of load. Bending inside, I will take sagging. Yesterday there was no time, I have not explained. Okay, now do one thing. Start. Now, bending moment at B. Tell the answer. See now. Hogging or sagging. See, this is sagging. See now. What is sagging? See here. See. This is sagging. Yes or no? This is sagging. Now, 58.17 is sagging or hogging. This is sagging. So, 58.17 is sagging or hogging. Tell the answer. 58.17 is sagging or hogging. If you take the sagging that way, that 58.17 is sagging or hogging. Pause, tell me now. I will make fully clear. Hogging. So, you write minus 58.17. That is what? It is 58.17, not sagging, that much hogging. See here. See here. See. Clear or not? See. Tell me. Tension on left side or right side? Tension on left side or right side? Pause, tell me. Tension is on left or right side? Tension is on which side? Little fast. Tension is on left or right side? You are delaying too much for giving answer. Tension is on left side. Left side tension. Therefore, at the point B, plot on left side how much? Plot on left side how much? 58.17. See, 49. Somewhere here. 58. I will use red color for the column. To avoid confusion, I will use red color for the column. Hope red is visible. It is, but red is not visible. Okay, black only. It is perpendicular member. 58.17. I will round off the values for the columns. Okay, then bending moment at J. At J. Look this side. Tell the answer. If you look this side, it is 28.37. 28.37 into 3. Correctly tell me. If I see here bending moment, sorry, 28.37 into 3 will bend like this. Tell me, sagging or hogging? 28.37 into 3 will bend like this. So, sagging or hogging? Common sense. Sagging or hogging? Sagging or hogging? 28.37 into 3. You imagine sagging, hogging. What? Sagging. That was sagging. Therefore, plus. What is the answer? Answer. Plus. Big answer. 28.37 into 3. Answer. 28.37 into 3. Answer. Answer fast. You. Ittotto answer ge. We are coming to closing part. Answer. Plus 85.11. Plus 85.11. That means what? 85.11 sagging. That much what? That much sagging tension is on the right side. So plot at the point J, right side by how much? 85.11. Right side by, see little bigger, 85.11. Lastly, bending moment at E, look this side is 0. 0. So your BMD will be this way and this way. Hatch some other way. This is the BMD for the column. If I want to draw elastic curve from here to here, tension is this side, it will this way bend. From here to here, tension is that side, it will bend like this. From here to here, tension is on the left side. From here to here, tension is on the right side. Fully clear? Tell me. Fully clear or not? BMD for the column. Now you can go to yesterday's class. If fully clear, now you can see yesterday's class. Yesterday there was time problem, so I did little fast. Today do one thing. After the class, you go to yesterday's class and study once again. Okay. Now, last member. Which one? I will do it here only. See, here only I will do it. CF member. CF member is loaded like this. So, if you simply support beam, it will sag this way. So, I will take, this is sagging. Clear? For CF member, see, CF member, load is from this side. So, I will take sagging positive. See, this member, this is sagging. This member, this is sagging. Clear or not? See here. This member, this is sagging. This member, this is sagging. Clear or not? First. Clear. Okay, start. Now, this is the point C, this is F. I want bending moment here. Bending moment at C. At C. Nodi, here see. This is sagging. Nodi. See the sagging hogging correctly. It will be clear. Bending moment C is, see now, this is sagging. But tell me, 45.66, will it sag or hog? Tell the answer. This is sagging. See, this is sagging. So, 45.66 is bending like this. Is it hogging or sagging? See there. 45.66. Is it sagging type or hogging type? First, hogging type. So what you write? You write what? Minus 45.66. Then, therefore, what? That means 45.66, what? Not sagging, that much hogging, tension comes on the right side. Or you can see here only, see, 1 minute. Tinker it. If you apply the couple here, see, actually this much is not required. Once you know the concept, see here, the crystal clear, this couple will create tension on the right side. Tell me yes or no. By looking only you can make out. It will create tension on the right side. Yes or no? Yes or no? By looking only you can make out. Or, I will tell you, there is a crude method. Want to know it? There is a crude method. Want to know it? I will use it later for frames. A crude method. Want to know it? Yes. If you write end moment with the closing bracket system, remember, then closing bracket. See, any member, you should write beams. You should write moment like this. Column, you write like this. Then you need not see anywhere. Which side is the tail? That side tension. Clear? TT. TT. TT means in the closing bracket, one side arrow, one side tail comes. Which side is the tail? That side tension. Tell me, where is tail here? Right side or left side? For this closing bracket moment should be in the closing bracket. You should not show this anti-clockwise like this. No. You should put closing bracket. Tell me, for this one, tail is left or right side? Right side. You close your eyes and what? Plot right side by how much? Plot right side by 45.66. Close your eyes. This value. This value is, see, this is 45.66. Tell me, bending moment at F. Tell me, tension which side? 97.17. Tension which side? Look here. Tension which side? Left or right side? See here. This couple also. Tension where? Left or right side? Here also right side. Why? See here. See, bending this way. So it is 97.17. Now, you also require bending moment at K. Oh, now you should be careful. At K required. For that one, calculate bending moment at K equal to, look that side, minus 45.66, hogging, plus 107.12 into, oh, I think if this is 2.215 meter, this will be 1 point, you calculate distance from there, any side you can see, 1.785 meter, okay, into 1.785, then minus what? 60 into 1.785 into 1.785 by 2. Tell this answer. Tell this answer. Minus 45.66 plus 101.12 into 1.785 minus 60 into that one into that by 2. Or like a simply support beam, you stand here, see, minus plus. Answer. What is the answer? That value answer. If you tell the answer over, then I will draw for those people who want superimposing principle. Answer. Plus 49.96. Okay. It is plus 49.96. That means 49.96 what? Sagging. Sagging. Sagging means tension inside. How much? Here write how much? Here write 49.96 sagging. It is a UDL is there. See. Here also BM is there. Okay. This is the BMD for column 2. Counterflexure will come. Fully clear? Now, this example, BMD for horizontal vertical member, completely clear means go back to last class. If any confusion is there, get it clarified. Full clear? Okay. Now, lastly, there are so many people who do not understand this. I am rubbing everything. Why? Over. Over now. BMD over. See. Now, this I am doing for you two people, those who majority of places, they draw BMD on superimposing principle. I will tell that also. But remember, that will not give correct BMD. It is only for academic purpose. It is not correct BMD. Correct BMD means you have to plot on the tension side only. You cannot use that one. But still, because people want it. Okay, do one thing. See here. I will draw the baseline. Okay, this color is not writing. I will use the same base color. 1 minute. Hello, itu. Right time, I am not getting that pen. Where I kept it? Here. Not here. Yes, usual problem. Here. See. I will draw the baseline here. See correctly those who want that easy method. A, B, C, D, E and F. Okay. I will tell you. First draw bending moment diagram considering only member end moments. Do not see loading. No loading, UDL, parabola, nothing. Joined by straight line. Why? Bending moment diagram only for what? Only for what? End moments. Crude method. I will tell you. Plot on the tail side. Very crude method. See here. Upper side. 111.01. Here. this member, upper side 47.97 joined by a straight line, that member, upper side 106.15, this side 138.14 joined by a straight line, that side 90, it is 111, okay, 92.48. There, nothing, zero, join here. Then this member, left side, why? Tail side. I will tell the students also, tail side, 50, somewhere here, okay, 58.17. Okay, this is 58 point, see this value is 58.17. Here 0 joined by a straight line. Here 45.66 right side. Here 97.17 right side. Join here. Now over this diagram superimpose the bending moment diagram for simply support beam. You should know the formula. Formula is for UDL WL square by 8. I will only draw. You should 30 into 6 square divided by 8. I am not showing calculation. 135. Somewhere here center is 135 full. Then hand slipped. Joint here. Okay. Then whichever is upper side but within the line is negative. Whichever goes below that one positive further negative. Here WL by 4 200 will come. 200 WL by 4 joined by straight line, joined by straight line, negative, positive, negative. Here WAB by L 150 into 2 into 3 divided by 5 180. Under the load it is 180, little more, 180 minus plus. Here WAB by L, you should plot on the loaded side. Load is this side. WAB by L 100 into 3 into 2 divided by 5 is 120 here. 120 here. Negative, positive. And here WL square by 8. 60 into 4 square divided by 8 is 120 here. Loaded side. Minus, plus, minus. But this will, that now if I draw elastic curve, hogging, sagging, hogging, hogging, sagging, hogging, hogging, sagging. Here, hogging, sagging, here, hogging, here, hogging, sagging and hogging. Now, this will not give you the correct bending moment where shear pose 0, the maximum will not come. Now I will do one thing. This is the BMD for academic purpose. Now, suppose I BMD from first principle, just to understand what I have drawn on tension side, I will draw once again here. Don't worry. Sir, how you can draw so fast? No problem for me. I will draw once again now. Don't worry about it. Tell me, both BMDs are same or not? Tell me, both BMDs are same or not? Tell me now. Both BMDs are same or not? Tell me, both BMDs are same? Both are same. But tell me, which BMD gives you complete understanding? Which BMD gives you full idea for bending moment variation? Superimposing principle or what? BMD drawn on tension side. Which one? Superimposing principle or BMD? BMD drawn on tension side gives you correct idea. Okay. Now, if you want, little time is there. Shall I give a small example why BMD on tension side is more perfect than superimposing? Shall I give an example? Shall I give a small example for you? Shall I give a small example? If you draw superimposing, it won't give you. Okay, now I'll do one thing now. A small example. Just because little time is there. See, do one thing. You consider a beam. Consider a beam. A beam, red color I will use, red better, black color. You consider a beam. Here. Consider a beam of any length. Okay. Of length 5 meter. You apply a load here of 200 kilonewton. This is 2 meter and this is 3 meter. Imagine there is a moment here and a moment here. I will call A and B and C. Simple beam. I will give exactly the fixed end moment. So it is a fixed beam. The moments are, this is 144 kilonewton meter. That moment is 96 kilonewton meter. That is, and now, can you find the reactions? Tell me. Can you find the reactions? Tell first. Can you find the reactions? Yes, I will find the reactions. Reactions are this is 70.4 kilonewton and this reaction is minus 200 is 129.6 kilonewton. Okay, now tell me, if you draw bending moment diagram on tension side, it is the correct diagram. See, I will draw. Those people who draw BMD on tension side, see here, BM at A minus 144. So hogging tension upper side 144. BM at B minus 96. Tension upper side of 96. BM here minus 144 plus 129.6 into 2 or minus 96 plus 70.4 into 3. You can do whatever you want. Answer. Tell the answer. Any side you look. Minus 144 plus 129.6 into 2. Is it plus 115.2? Tell me. Is it plus 115.2? Tell the answer. Is it plus 115.2? Yes. Plus means sagging. It is 115.2. This is the real BMD. This is the BMD on tension side. That is tension side hogging, sagging and hogging, and that means what? See, this is the two corner pressure points here. So that clearly gives you BM at A is what? This will clearly tell you. At A, your BM is 144 hogging. At B, BM is 96 hogging. And at the point C where that load is there, BM is 115.2 sagging. Fully clear? Tell me. This will give correct idea about BMD because BMD on tension side. Tell me. Full clear means I will go to superimposing principle. Okay, now those people who go to superimposing principle, it is not correct. No, what they will do is draw the baseline. BM here is, see, minus 144. Tension on the upper side or tail side, they will plot 144. Here, they will plot tail side 96. Remember, BMD to superimpose, what happens is, end BM comes, see, at the end BM comes correctly. Problem is for intermediate. And then, here, then what they will do? They will join by a straight line. This is fully negative. Then they will superimpose the bending moment due to simply support beam. That is, see here, it is W L by 4. Sorry. It is W, not central. W AB by L. How much it comes? 200 into 2 into 3. How much answer? 200 into 2 into 3 divided by 5. Tell the answer. That is the full ordinate. 200 into 2 into 3 divided by 5. Tell the ordinate. 200 into 2 into 3 divided by 5. 240. 240 is this full value. Then they will tell negative, positive and negative. Now if you want BM at this point is, here BM is 144 negative hogging. Nodi, same as our answer. BM here is 96 negative hogging. BM here, oh, you cannot get it. If you want, see, this is the resultant BM. If you want BM here, what do you have to do? See, I'll do one thing now. See, this 240 is the full value. What do you have to do? First you have to calculate what is this value. Tell me. If it is 144 here, 96 here, it goes this way by interpolation. Tell this answer. This is 144 here. It is 96 here. Length is 5 meter. You go by 2 meter by interpolation. Tell this answer fast. That answer fast. By interpolation. Left side is 144. Right side is 96. That is for a length of 5. By interpolation, that answer 124.8. That value is 124.8. Therefore, the real BM at C is, this full is 240. From 240, you have to subtract 124.8. Calculate the answer. If any answer comes other than this answer, from tomorrow, don't come to my class. If you struggle that way, you get the BM. Tell the answer. Plus 115.2. It will come plus 115.2. Correct. See. But yeah, now, if it is point load, okay. If it is UDL, further problem. Where shear force crosses the baseline, that ordinate is not known for you. It will not give correct answer. Therefore, clear now? Both superimposing and correct principle, both are clear. What correctly you are doing and superimposing, both are clear. Okay, now, if UDL is there, further problem, why? It will give you central value, WL square by 8. But maximum is not center, it is somewhere else. That value is not known. Therefore, remember, practically for knowledge, correct is what? Superimposing principle or BMD drawn on tension side. Which is correct? Both are correct. This is not wrong. So, the real BMD will be what? Which is the BMD I will draw? From next class onwards, when I continue the class for you, BMD will be drawn on tension side or compression side, but universally tension side. Why? RCC, where BM ordinate is there, tension, that side you require steel. Now 1 minute. See, if you draw BMD on tension side, see the advantage here. Suppose, for example, for a beam here, see, for a beam, this way frame. Suppose you draw BMD on tension side like this. If you write this way, then it means that when we go to RCC, see, if you provide tension steel, tension at the top, tension bottom, tension top, tension right side, tension left side, tension right side, tension left side. So it is easy to identify the location or zone where tension comes. Is the concept fully clear? If fully clear, I will close this class. Therefore, tomorrow, remember, class will be there, not here. Where? Tomorrow, the question which we solved, one question with all fixed supports and one question with the 2 hinged support, we solved by SDM. Tell me, we have to solve by which method now? What is pending? What is pending now? That question, what is still pending? I can finish in one class. What is pending? That question, MDM and Kani, both I will complete tomorrow. But tomorrow, remember, will be Zoom. I won't do in YouTube, because if I go to YouTube, I cannot, because you already know everything. I will go to YouTube when I tell something fresh, or what I tell when it is useful for you. Otherwise, I will fast announce a timing little later when I am starting systematic course on YouTube. Not now. I will announce the class. I will upload a video. I am planning to start some course systematically on YouTube, basic structural engineering. That is first engineering mechanics. That I will tell you later. You wait there and you get the notification. Okay. Okay, thank you. Tomorrow we'll meet back in the Zoom class.